Hi everyone, this is Mr. Cardoso again, and this is our next lesson on hiding information on section 6.4. We did part 1 already, where we talked about why we want to hide information or protect information. And so we talked about this specific example with our fraction class. So here the problem was we don't want the denominator to be 0. So what we did was we put a private in front of the denominator. That means the only one who can access directly this denominator field is whoever's writing this fraction class. We can only edit this, right? We can access the den field directly because it's private. So if you make it public, or in this case, for example, if there's nothing public nor private in front of this, that means it's package public. It means anything in the directory will be able, any class within that directory will be able to access the num field directly. But in this case, den can only be accessed within this fraction class. So, like we said before, if we, let's go down to the interactions panel, and let's say I make a new fraction, new fraction, 1 comma 2. So I can go f1.num get 7, and that's fine. And now if I print out f1, I get 7 over 2. So I can access it. I can also, change it. So this is me changing the numerator. If I want to access it, for example, I can make some other variable, and assign it the value of f1.num. So that's me accessing the variable and then assigning it to some other variable. And I can just access it directly, right? I can change or modify or mutate the num fields as I've done here. So I've changed it from 1 to 7, and again I can do that directly using the num field. Of course I can't do that with den because we made it private. And again, anytime I'm in the interactions panel here, assume that I'm in a different class. So I'm in the same directory, and it tells you your working directory here. I'm in the same directory, but I'm in a different class. So if I try to change the den field to, let's say, 4, it says no field in fraction has name den. It's basically saying that field doesn't exist. From compiler to compiler, you might get a slightly different error. It might say it exists, but it's private, or it might say it exists, but you don't have access to it, something along those lines. But here it says there's no field that has den. And we know there is a field that has den, but it's just private, so we can't access it outside. So we can't mutate it, we can't change it. Whenever you want to think of that word mutator, think of, if you want, think of Teenage Mutant Ninja Turtles. They changed from, regular turtles into Ninja Turtles that could, do ninja. So mutator means changing it, and I can't change it, I can't mutate it, I can't access it either. So I can't go, other variable gets f1.den. For example, again, same deal. It doesn't let me do that. So what we do then is, what if we do want to allow the user to change these, right? But before I get to that, we already, in the last video lesson, we talked about as well when we, what about the constructor? So for example, what if the user, the secondary programmer here, puts a 0 in this field, or they ask the user to give a value for the denominator and they put a 0, or you do some sort of mistake like integer division, and you get the result of a 0. Well, we've also safeguarded that information through the constructor by writing this code. So if the denominator ever comes in as 0, we send a message saying you can't do that, and we set the denominator to 1, and we tell the user that we're going to do that, or the secondary programmer, just so there's no confusion. And if it's not 0, then we set it. So that's the failsafe through the constructor. So now we've got to go through And so we've created, in the last lesson, at the end, we created our setDen method. Our setDen method takes in an integer and sets it. So basically it checks first, though, if that number is 0, then it says you can't do that, and we basically won't change anything. We won't do anything, but we send that message. Otherwise, we change it, right? So that's how it works. So let's just see a demonstration of how we actually, if we wanted to set the denominator. So we go f1.setDen to 4. And now that works. So now if I print f1, now we get that here, right? So it's calling the setDen method on f1. It sends 4 in. 4 gets mapped to d. d is not 0, and so it sets it. And then we print it out, and you can see that 4 is in the denominator. Now, if we went f1.setDen 0, it says, hey, you can't do that. So it's basically, it's coming into here, and it says denominator remains unchanged. So this is what we call our mutator method for this, for the fraction, or for the den field. So we can say mutator method or setter method for the den field of the fraction class. Checks to make sure that the d parameter is not 0 before checking. And I could add to these comments and say, you know, and if it is 0, we'll send a message, blah, blah, blah. But you get the gist of it. I just want to save time in this video. So next, now we can set it, but what if we want to access it? Yes, we can see what the denominator is here by printing it out. But what if we wanted to, you know, get it and, you know, let's say we wanted to make a variable called, you know, f1 denominator. As the secondary programmer in our other, you know, our other programmer wanted to get that denominator. How could they get that denominator? Well, they can't go f1.den, as we know already. So how do we access it? We can't do setDen. setDen returns nothing. It's a void method. So in that case, we'll have to do a public, and what's the return type? The return type will be the type of the field that we want to return. So we want to return the denominator, and so that's going to be int. So public int, and we'll call this, you guessed it, getDen. And that does not require any parameter. Usually getter methods, so that now we have over here, we have getter method, aka, in other words, accessor. And accessor methods allow you access, so basically just to read what the value is of a certain field that happens to be private. So most of the time, getter methods do not have any parameters, and they return what is the same type of the field that we are returning. And setter methods usually are void. They don't need to return anything. They don't have to be. These are just general rules. And we usually take in the parameter for what we want to set that field to. And usually that matches the data type of the field, right? So here we're accessing, so let me just write quickly. Accessor method for the den field. Okay, let me just close that. Now, so basically in this one, we don't have any limitations for what we want to do, so we can just, they're just returning in secondary programmer, so we can just return this .den or just return den. Okay, so we compile that. Now as the secondary programmer, you know, you can create your fraction. So we create our fraction there, f1, 1 over 2, and if we wanted to set to the denominator, so we can go f1.setDen to, let's say, 11. So now this fraction f1 will be 1 over 11. And if we wanted to get that value, for example, for whatever reason the secondary programmer wanted to store it, f1's den, we can say f1, if int f1's den, we just make up a variable, equals f1.get den, just like that. And f1's den, if we print that out, we have 11. So we can now access it and store it into variables or print them out or whatever it is we want to do with that private field, in this case the denominator. Now, I said that usually getter methods or this is the accessor method, usually doesn't have any parameters. But you could put something like, an int PIN number or something like that, or a password, and check to see if the user has that password, then they can access that information. So that's another place where private fields could be useful. Let's say you were making a bank account object, and your bank account object had, you wanted to access, say, the balance or something else, or be able to withdraw money or something like that. Then you can put a password field into your parameter and check if that password field matches the one that was initially set. So we can get to examples like this more later in detail, but that's a good example. Like you could put a password, you could password protect your accessor methods so that you're only returning the result if, and you put an if statement in here, if the password matches, some other field that you might have up here that is in fact the password field that perhaps the user set themselves in the constructor. So that's another way that you can play with accessor methods. But generally, accessor methods are there because, so in this case, just to review, we didn't want the denominator to be set to 0. So we made it private so that the user did not have direct access to it. In the constructor, now we check if that denominator is coming in at 0. If it is, then we send a message and we set it to 1. So basically we're blocking it from becoming 0 here. And then if the user cannot, change the denominator, so this is a problem. So we make a method for them to get around this problem. But of course, in that method, we put in a little if statement to make sure that, again, they're still not setting it to 0, because this is the key aspect. We don't want them to set the denominator to 0, so we'll check that there. But because of that, they can no longer access the den field, so we make an accessor method so they can get around that problem as well. And again, all of this is communicated through comments. Now, these aren't very good comments, but make sure you want to put the comments as we've discussed in the methods like @param and @return, and describe exactly what it is you're doing here for the secondary programmer, because there's another programmer who's going to be using this program. All right, that concludes pretty much our hiding information lesson. So this is the part 2 of hiding information, and thanks for joining me, and I'll see you next time.